Okay, so another example. So let us take little l2. So this is a set of all x equals xi sequences such that sigma mod xi square is finite, I equals 1 to infinity. And what is the norm x2 is square root sigma I equals 1 to infinity mod xi square. Okay, so this is the space. So now we are going to define two operators. So T of x is a sequence 0, x1, x2 and so on. So you push it to the right, put a 0 in the front, so this is called the right shift operator. Similarly, S of x we are going to define as x2, x3 and so on. So you push it to the left and you get rid of the first coordinate x1, and this is called the left shift operator. Both of them are continuous linear operators because norm Tx is equal to norm x in fact, and norm Sx is less than or equal to norm x. Okay, so we have these two are continuous linear operators. So one can easily check that T star is equal to S and S star equal to T. Okay, so here of course we are identifying, remember L2 star is the same as L2, so that is why they are in the same spaces. Okay, fine. So now we look at some properties of this adjoint. So the first important property, so VW Banach, A from dA contained in V into W is densely defined, so that the adjoint is defined. Then A star is closed. Okay, so proof. So to show G of A star is closed. Okay, so we take Vn converges to V in W star, and A star Vn converges to F in V star. And what must we show? We have to show two things now, because we are dealing with unbounded operators which may not be defined everywhere but only on a certain domain. So first we have to show that V belongs to domain of A star, and second, after that we can show that A star B equal to F. So we have to show both these things. So okay, but what is, take any U in domain of A. What is the definition of the adjoint? So A star Vn U equals Vn AU. Okay. Now you pass to the limit, so you get F U equals V AU. Okay. So mod VAU is therefore less than or equal to norm F times norm U. So this implies that V belongs to D of A star. And this condition here, which is true for all U in D of A, tells you, this one tells you that F equals A star, because it satisfies the defining condition for A star U, A star V, sorry, A star V. Okay, so this proves this proposition. Okay. Now the graph of A and graph of A star are related by a very simple relationship. So let us now define script J from W star cross V star into V star cross W star. So we take Vf and map it to minus Fv. So we are just flipping the coordinates and putting a minus sign in front of it. Then proposition VW Banach A from dA contained in V into W densely defined J as above, then J of GA star equals GA perp. So you see the annihilator and the graphs and annihilators, they all come together. Okay, so proof, 2 lines. So you have, let U in dA arbitrarily so Vf in GA star, this means what? F equals A star B, and that implies F U equals V AU. This is for every U in D. I am not putting the subscripts, we know where these things are acting, and therefore, okay, so this is equivalent to saying minus F U, so this is V star V if you like, plus V AU, this is in W star W, equal to 0 for every U in dA. Now UAU is a typical element of the graph of A, and this tells you that minus FV is killing all of them. So that means that J of VFF belongs to GA perp. And all these implications work both ways, and therefore that proves this proposition. Okay, so now we come back to the question of bounded operators. So we have the following important proposition. VW Banach A from dA contained in V, taking values in W, densely defined and closed. So we are making an extra hypothesis on this. Then the following are equivalent. 1. D of A is V. A is bounded. D of A star is W star, and 4, A star is bounded. Okay, all these, and in this case we have everything is a continuous linear operator now. So norm A equals norm A star. Okay, 1 implies 2. dA equals V, so A is defined on the entire space, they are all Banach spaces, and dA and A is closed, that means the graph is closed, so this is just a closed graph theorem. So that's it. Okay, now 2 implies 3. A is bounded, Therefore, we want to show dA star. So, let V belong to W star. We have already done this calculation a few minutes ago. So, if you take U in D of A and then you take VU, V times AU, and take the modulus, that will be less than or equal to norm V into norm AU, which is less than or equal to norm V into C times norm U in dA. Okay, so this implies that V is in dA star by definition, and therefore dA star equals W star. We did this a little earlier already. Okay, so now 3 implies 4. We know that A star is closed and dA star equal to W star. Therefore, again by the closed graph theorem, we have that A star is a bounded linear operator or continuous linear operator. So, now we only have to show 4 implies 1. Okay. So, first claim, dA star is closed. So, if A star is bounded, then dA star is closed. Okay. So, let Vn Vn converges to V in W star and Vn in dA star. Okay. Then norm of A star Vn minus V is less than or equal to C times norm Vn minus V, because A star is bounded. Vn minus Vm, Vn minus Vm. Vn and Vm are all in dA star, and this is A star is bounded, that is statement number 4, and therefore you have this. So, this implies that A star Vn is Cauchy. So, A star Vn converges to some F. Okay. But then, so Vn converges to V, A star Vn goes to F, therefore, but A star is closed, and therefore this implies that V belongs to D of A star and AV equal to F. Therefore, we have that dA star is closed. Okay. Now we will set G to be G of A, graph of A. This is contained in V cross W, okay, and H to be 0 cross W, which is again in V cross W. Okay. Now, by hypothesis, this is closed and this is trivially closed, so there is no problem. Okay. Okay. And now, what can you say about G plus H? G plus H, so you are taking an element in GA. How does an element in GA look like? The first coordinate is from the domain, second component is A of U. So, U, A, U. And here they are taking 0, any element in W. So, when you add these two, you will get elements in the domain and any element in W. So, this will be dA cross W. Now, GA perp is J of GA star, flipping and putting a minus sign, and therefore we have G perp plus H perp. Now, what is H perp? So, H perp, you want to kill everything here. So, the second one, if you want to kill all of W, you will have to be 0, and if you want to kill 0, any element is fine. So this will be V star cross 0. Okay, so if you add these two, so you have V star here in the first component and anything, so this will be V star cross, second component is 0, and in GA star, the first component was domain of A star, I have flipped it, and so in J, so this will be domain of A star. Okay, and then this is given to be closed, because this is closed and V star, so this will be closed. And then we proved this theorem, that this implies, this is the only part of that theorem which I did not prove, this implies that G plus H is closed. That is, G plus H is dA cross W, therefore dA is closed. Therefore dA equals dA closure, which will be equal to V, and that is the first part of the theorem which we wanted to prove. So this proves the equivalence of all the statements. So now let us, so for all U in V and V in W star, you have VAU, this is W star W, equals A star V U, this is V star. Okay, so mod of VAU is therefore less than or equal to norm A star, norm V, norm U. Okay, so V for every element in the dual space, so for all V in W star, and then we from this we saw corollary, because what is the corollary of the Hanbanach theorem? If you, in fact it is a max, namely the norm of the vector is sup of over all norm V less than or equal to 1 VAU. Okay, so this will be less than or equal to norm A star, norm U, and this implies that norm A is less than or equal to norm A star. On the other hand, the same relationship will tell you mod A star V U is less than or equal to norm V, norm A, norm U, and this is now a dual element, so you just have to take the supremum over all U, and therefore this tells you that norm A star B is less than or equal to norm A times norm V, and therefore you have norm of A star is less than or equal to norm V. So we have both inequalities, and that shows that the two norms are equivalent. Okay, so we will continue with some properties of the dual, so of the adjoint. So we will connect what is the relationship between the range null space of an operator and the range and null space of the adjoints, and in between some annihilators will have to come in. So we will see how these things work out. Okay.